Now that you know how to obtain partial derivatives of functions, it's probably time to move into partial implicit differentiation. You'll see that this is basically exactly the same as implicit differentiation. The only difference is now we'll be dealing with functions z of f, x, y, or sometimes functions of more than just two variables. From now on, it will be even more important to read the question in detail, because for partial implicit differentiation, both y and x are variables, and it's z that is a function of x and y. It means you're doing the same as you were doing before for implicit differentiation. Before, if you remember, whenever you had a y, because we assumed that y was a function of x, whenever you encountered that term, you would keep a dy dx like this. The big difference for partial implicit differentiation is that now whenever you encounter a z term or something that depends on x and y implicitly, you will keep one of those partial terms. For example, if you're looking at the partial derivative in respect to x, you would keep it like this. If it's in respect to y, you would do it like this. Again, there's nothing like seeing an example to make sure that you understand the concepts and that you can extend them to partial implicit differentiation. So let's just do it. You can also find this example in the lecture notes. This is example number 1. Let's say that we want to calculate the partial derivative in respect to x. As we've seen before, for implicit differentiation, you would be applying d dx to both sides and differentiating. Whenever you would encounter y, you would keep a dy dx. In this case, this is very similar, but whenever you encounter a z, you will keep a dz dx. And y here is a variable, it is not a function of x. Therefore, when you're differentiating in respect to x, it is a constant. First step that you do is you apply the derivative operator to both sides. It helps that when you write, you give some space so you can do it and everyone can follow your steps. Let's start slowly and describe every single step so that no one gets lost. In this case, we actually need to use the product rule and also understand that we need to keep a dz dx. Therefore, we get 3x to the power of 2 z squared plus, remember we're just using the product rule. And then here we differentiate z squared times x to the power of 3. This is 2z. We keep a dz dx because z is a function of x. It's also a function of y, but now we're differentiating in respect to x. And we multiply by x to the power of 3. We go to the next term, which is relatively similar. We also need to differentiate x times everything else plus the derivative of z times the one that involves x. Therefore, you can get minus 5 y5 z plus, but because there's a minus, it also becomes a minus. And here, all you need to do is keep dz dx. And this means you get minus 5 x y5 dz dx. As usual, this can be very long. Make sure you have space in your piece of paper when you're solving this. And this side, it is actually slightly easier. There's no dependence on z. Y does not depend on x. This will be 0. Means this is equal to 2x. As with implicit differentiation of just functions of one variable, the next step is you want to combine the terms that contain dz dx, and then you want to solve for it. In this case, we have 2z x to the power of 3 and also a minus 5x y to the power of 5. That is being multiplied by dz dx. And to the other side, we already have 2x. And we're going to take 3x squared z squared minus, because we're taking it to the other side, x squared z squared. And there's also a term here that becomes plus 5y to the power of 5z. And finally, we can solve for dz dx by taking this to the other side by dividing, which implies that dz dx is equal to 2x minus 3 x squared z squared plus 5y to the power of 5z divided by 2z x to the power of 3 minus 5x y to the power of 5. And this will be our final answer. For implicit differentiation of functions of one variable, it is okay to leave the implicit function here. In this case, z. You don't need to further simplify it. And in most cases, that will not be possible and definitely not easy. So you could leave this as your final answer. What you can now do is calculate the implicit partial derivative dz dy. And you can find all the details in the lecture notes that I'm also showing here. I think this is all about practicing. If you encounter any problems, just let me know. In this case, partial implicit differentiation is really just about you using differentiation rules. The product rule together with chain rule, quotient rule. And the only thing you need to understand is that when you're differentiating in respect to x, y becomes a constant and z is a function of x. So you need to use chain rule. And when you're differentiating it in respect to y, then it's x that is a constant. Z is still a function of y, so we still need to use chain rule. If you apply this and you know how to differentiate functions, and with some practice, implicit differentiation becomes also relatively simple, even in the case of partial derivatives.